In this video, we'll be working with the mental subtraction strategy known as compensating. This is a really neat strategy because as soon as you can visualize it with a number line, it makes a whole lot of sense. Before we get to our mental subtraction, let's examine how we'll be using our number line. So imagine you go for a drive and you start driving at mile marker 10 and you stop driving at mile marker 15. You might be interested in knowing the distance that you traveled. You'd be looking for the distance between these 2 points. And the way you would calculate this is by taking 15 minus 10 and discovering that you had traveled a total of 5 miles. So we can think about subtraction as the distance between 2 points on a number line. The next key observation that we have here is that we have lots of different pairs of points that are also separated by 5 units. So let's draw another 5-unit line segment right here, and let's notice that we could move it. We could move this such that if we had started at 8 and ended at 13, we still would have gone 5 miles. There are lots of pairs here. We could start at 13 and end at 18. We could go up and down the number line, and we could have lots of starting and stopping points that are separated by 5 units. So let's just summarize these 2 main points that we'll be using. We can think of subtraction as the distance between 2 points on a number line. Our second main point was the distance does not change if we shift both points the same amount in the same direction. Let's use this to do some mental subtraction. Our first problem is 32 minus 17. So we'll start this one by looking at the number line, and then we'll see how we can relate this to mental work. We note that we have the 2 points, 17 and 32, and we'll think of the subtraction as the distance between these 2 points. And we will then think about shifting the 2 points by the same amount in the same direction. One way we might do this is we might say, oh, let's add 3 to both numbers. So let's shift this line segment here 3 units to the right. So what did I do here? I shifted 3 units to the right and 3 units to the right. So this makes the problem into 35 minus 20. 35 minus 20 is much easier for me to do in my head. 35 minus 20 is 15. Often, we'll use this strategy to have the second number in our subtraction problem, the subtrahend, be some multiple of 10, because it's usually easier to subtract multiples of 10. Now, we could have done this a different way. So let's take our line segment back to 17 and 32, the distance between those numbers, and we could have gone to the left. So let's say that we went 2 units to the left. If we went 2 units to the left, that would be 30 minus 15. In this case, maybe 30 minus 15 would be just as easy for you as 35 minus 20. There isn't a right or wrong way to do this as long as you're moving in the same direction, the same amount. This strategy does not work if, for example, we decided to make 32 into 30 and to make 17 into 20, then we would have changed the length of our line segment. We would have changed the distance between the 2 points. So key idea is that shift in the same direction, the same amount, into a problem that's easy for you to do mentally. So in general, we want to make it easier on ourselves, not harder on ourselves. So I wouldn't have necessarily shifted to 33 minus 18. That wouldn't be easier for me. So here I chose I chose a multiple of 10 as my second number, the subtrahend. Let's do another example. This time let's start with the mental work and then draw it on the number line to see why it makes sense. So if I want to mentally subtract 61 minus 38, I might want to make the 38 into 40. So I added 2 to the 38, so I'll need to add 2 to the 61, turning it into 63 minus 40. 63 minus 40 is 23. So if I were recording this on the board as I talked, I'd say, well, I want to make 38 into 40. So I'm going to add 2, which means that I also need to add 2 to the 61. So I made this into 63 minus 40, which is 23. So now let's look at this on the number line. I have 61 and I have 38. I plot both numbers, and I want to find the distance between the two numbers. And what did I do? I shifted to the right 2 units. That's the equivalent distance. I didn't change the length of my line. Let me actually draw a second line in here. So I will put a green line in where you can see that these are the same length. So 63 minus 40 was the same. Now I can always go back and double check my work. I could take 61 minus 38, do this by hand using my standard algorithm here, and I get 23. Let's do an example without a number line. We used the number line on convenient examples that had numbers fairly close to each other where it was easy to draw the number line and conceptually understand what was going on. And now we can apply it with numbers that would be more inconvenient to show on a number line. So here we have 456 minus 299. And right away I can see that 299 would be really easy to change into 300. So I'm going to add 1 to both numbers. I'll have 457 minus 300, which will give me 157. What did I do? I added 1 to both numbers. This made it 457 minus 300 for a difference of 157. Again, our goal is to make it numbers we can easily work with in our head without actually writing them down on a piece of paper. The more you do, the better that you get at this strategy. And as you get familiar with it, it becomes lots of fun.